Good morning, good everyone. I'm going to talk about the resistance to amitraz, ivermectin, and alphacypermethrin, and Rhipicephalus microplastics, and their risk factors in Ecuador continental regions. First, I want to begin with a quote. I'm among those who think that science has great beauty. A scientist in his laboratory is not only a technician, he is also a child placed before natural phenomenon, which impress him like a fairy tale. This is from Mary Curie. What about ticks? I'm going to talk about introduction about ticks. Exotic ticks. They are obligated to connect to parasites, so they just feed from blood of the host. The species that affect more the cattle around the world as Rhipicephalus microplus in first place. They causes direct and indirect damage that I'm going to talk later. And about the world, it causes $2 to $3 billion of losses about everything associated with ticks in the world. Also, ticks are the second most important vectors after mosquitoes. And Ecuador is not an exception because we have a tropical and subtropical area, a perfect habitat for this tick. The problems causes about ticks increase with appearance of resistance to the parasites, and it get difficult to control and management of ticks. In Ecuador, Rhipicephalus microplus affects 69% of cattle in non-published data, and Emblema cahenensis is the second tick that affects cattle with 28% of the samples. About various theses and pre-grade and master theses collected in Ecuador. Well, what are the direct damage about ticks? It's caused that milk will decrease the production of 80.9 milliliters day per tick. They will decrease the feed consumption 1.29 kilograms per 50 ticks per day, and they will lose weight. They will not win the in a good weight, so they will lose 0.5 kilograms per tick per day, and also blood 40 to 50 liters about tick per year because of they just feed about blood. So for 50 ticks, they will lose all of this. And economic losses about South America, it's from 14 to 18 million dollars per year associated with the diminution of production of milk, meat, cattle mortality, and of course, the cost of control with the parasites and others. What's indirect damage? Of course, the development of resistance, the increased use of pesticides that is bad for the environmental and the public health, the increased use of antibiotics to control the secondary illness cases bad, caused bad ticks, the death of the animals and the environmental contamination for the pesticides and the milk and meat contamination also for the pesticides. All of that are more money spent infructuously for the farmers. And what's the problem with Rhipicephalus microplus is that it's not from here from South America. It is a species came from La India. From La India went to Madagascar. Madagascar went to South Africa to Brazil. From Brazil spread for all over South America except Chile. And then this tick went to Australia and also was in USA, but they eradicate for complete this tick, so they don't have more problems with Rhipicephalus microplus actually until the frontera to Mexico. It's important to know the cycle of this tick because it's one hot cycle, so one tick could change from 3 phases on the cow, could be larvae and nymph and an adult on one host, and then the tick will lay eggs at 2,000 to 3,000 eggs per tick. So imagine this is really complicated because one tick will be 2,000 new ticks, and you can see in this grace and that we have a lot of larvae that will be ready to cling to the new hosts. And what about this project, resistant to amitraz, ivermectin, and alphacypermethrin of Rhipicephalus microplus ticks and the risk factors in Ecuador continental region? First, the objectives. The general objective was to evaluate the spatial structure of resistance to the acaricide, amitraz, ivermectin, and alphacypermethrin. and Ecuadorian cattle farms located between 0.5 up and down degrees of the equator line. The specific objective was to evaluate the level of resistance and the dose responses, to map the distribution and density of resistance to acaricides, and to statistically analyze the risk factors potentially associated with the presence of resistance. The study zone, as I said, we work with 96 farms, cattle farms, up and down 0.5 degrees from the equinoctial line, the equatorial line. And the methodology, we have field work, lab work, and data analysis. In field work, we made a survey to obtain the management variables to the risk factors. And also we collect 50 ticks per farm to go to the lab. And in the lab, we made a bioassays to determine the resistance of amitraz, ivermectin, and alphacypermethrin. And with the data analysis, we use quantum Gs and RStudio to determine the spatial structure and the possible risk factor associated. In the lab, to determine the resistance, we use the BSI library package test that was recommended for FAO for the determination of resistance. So we have ticks, adult ticks. We wait to have larvae in the laboratory. Here you can see the larvae that are susceptible to acaricides. They are all that. And in the video, you can see the larvae that are resistant to the different to the different acaricides that they are. They have a different structure. They look alive, and if they walk, they are considered to alive. The results analysis resistance, the first results. The resistance in general, we have 71% of resistant to amitraz in all the farms, and for ivermectin, 69%, and for alphacypermethrin in third place, 63%. What about regions? We can see that, for example, in Amazonia, the biggest percentage of resistance is for amitraz with 86%. Also for the Andes, it's amitraz, but for the coastal zone, we have more resistance to ivermectin than from the others. And in the three zones, the alphacypermethrin has the less percentage of resistance. What about resistance levels? This is important because we divide about 4 formulas to susceptible, to medium resistance, low resistance, and high resistance. And we can see, for example, through the amitraz, we have more high resistance. And that's important because it's difficult to control this resistance level. For ivermectin, we have similar from medium resistance and high resistance. And for alphacypermethrin, we have more medium resistance. Low resistance could development in the future in susceptible farm or in a more resistant farm. All depends about the management in the farm. So we can see here the farms multi-resistance to more than one or more than one acaricides. And we have, for example, the farms that are resistant to 2 or 3 acaricides in the study. We can see in blue one, the blue ones are the susceptible farms to the 3. And divided in colors about amitraz, ivermectin, and alphacypermethrin. About the probability analysis and the linear regression, we can see that to obtain the 1990 lethal doses, it's impossible to use this concentration. You can see it's kind of 8 million times more than the stock doses, so it's impossible to use that. And you can see with a linear regression that the resistance goes with the concentration, more concentration, less resistant, but never going to 0. So we maintain that the population of these are resistant to these acaricides. About risk factors, amitraz is has associated to use amidins in the last year, and we have for protective factors the precipitation and the precipitation the bio-15. So the precipitation is a protective factor, and the use of amidin it's a direct correlated factor to develop more resistance in amitraz. About ivermectin, we have for management factor also that ivermectin, the use of ivermectin last year will increase the probability to development of resistance to ivermectin. And for protective factors, we have rainy days, the precipitation, B13, and NDVI of August. And for alphacypermethrin, we don't have environmental factor associated. We just have the use of pyrethroids in the last year. So that's important to know. And what about the spatial distribution? We know that we have hotspots in Maraví, that is a coastal province for the three acaricides for amitraz, ivermectin, and alphacypermethrin. The three of them has more resistance hotspot here in Manabi. So it is consequent risk factors, and some with less rainy are more resistance, as Manabi zone. It's a coastal zone. It's a drier zone. For the conclusion, we know that amitraz has 71% of resistance, ivermectin 69%, and alphacypermethrin, the third one, 63%. Alphacypermethrin is the new one. One of the latest acaricides in the market, but maybe in the next year, if we don't manage in a good way, we will have exactly the same resistance for the other ones. The risk factor, the resistance is associated with management and environmental factors, as we saw. And with about spatial distribution, the resistance spatial distribution showed hotspot in Manabi for the three acaricide use. So thank you to hear that. I have to acknowledge to the coordinators, Richard Rodriguez and Sofie Van Benbeck from Central University of Ecuador, and University Catholic University of Louvain from Belgium, and the collaborators Lenin Ron, Susana Arciniegas, de Condorosco, Paola Lagas, and Diego Caroa, who made this project possible to be here in this moment. Thank you so much for everything, and thank you to hear this presentation.